These are note 16. This is section 12-7 in your book, page 768. Feel free to follow along in the book. This is the quadratic formula. This is now your fifth way of learning how to solve quadratics. We should have done the warm-up already in class. This is reviewing to solve by completing the square. Our essential question is, how do I solve using the quadratic formula? So this should already be written down. Here are the notes. So copy this down, pause if you need to. So it says you can find the solution to any quadratic equation using the quadratic formula. So it doesn't matter what it looks like, what numbers are where, as long as it has an x squared term, you can solve it this way. So that's a really important thing, because sometimes you try to pick which method to solve and you're not sure. Just know that you can always use the quadratic formula. This is the quadratic formula. So you just have to plug in the numbers and solve. It does take a little bit of time. There might be an easier method, but this is reliable, and as long as you calculate everything correctly, it will be correct. So one of the really important things is to make sure it is equal to 0. So notice that it equals 0 right here. You got to make sure it's set equal to 0. Let's say there's a number or some term on this side. You have to add or subtract it over here. You might even have to combine like terms, but it has to equal 0. So add or subtract everything to get it on one side. And then it looks like this. I'm going to try to show with color. A is your coefficient in front of your x squared. It will go into the formula in two places, right there and there. And then B is your coefficient in front of the x. Also, always take the sign in front, so I'll put the plus B. So if it's a negative, you have to bring the negative. The formula does have a negative here, so if it was a negative B value, like if it was -3, it would be -3, and it would cancel. So this minus is always there. So your B value goes here and here. And then the last one is C. Let me use yellow. It's pretty different. Here's your C value. It's just the constant. It would go right here. So you can tell that's where the A, B, and C get plugged in and substituted. Remember, if it's a different variable besides x, you can change this instead of x. Maybe it's t squared and something t. So this would be t equals. So just remember the variable matches. We don't always remember to do that, but try to remember if it's an x, write it at x here. If it's like a t, write a t or a v. Make sure your variable matches. So anyways, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. It's really important you know this division line goes in front or under the -b as well. So it always has the squared, it always has this 4, it always has the 2, the plus or minus is always there. The things that change are your b values, your a values, and your c value. So you just substitute them in. It really is just following the directions of the formula and then learning how to calculate it. Always use order of operations. I usually start inside of the square root, do the b squared, minus it's 4 times a times c, so I calculate that. And I'll show you in the example how to do it, but just follow PEMDAS, order of operations. All right. So here is an example. Pause if you need to. Scoot that over. Okay. There. Okay, so here's your example. It's 2x squared plus 3x minus 5 equals 0. The first thing you want to check for is, does it equal 0? Yes. And then you want to identify your a, b, and c. And then substitute into the equation. So I think I'm going to write just a couple steps just to make sure you know what to do. Step 1, make sure it equals 0. Step 2, what does A equal? B equal? What does C equal? Step 3, plug into the equation and solve. Plug in and solve. It is useful to have steps. That way you can follow them no matter what your equation looks like. So here's just some short steps. Again, set it equal to 0. This one is. Find your A, B, and C. Let's do that right now. I'm going to try to match the same colors from above. So my A value, I did blue. So I'm going to do A is 2. And then I have my B. My B value is 3. And then my C value, take the sign in front. It's -5. Oops, I forgot to write that. My B value is 3. It's hard to see the -5, so I'm going to also write it in pen. There. Okay. So those are my A, B, and C values, and then I just have to substitute them in. So I start with -B. So I've got B here and B here. Ooh, I don't know if I have enough room. All right, I'm going to go ahead and write it underneath instead. So I'm going to go ahead and substitute in. I'm going to just kind of put this here and fill in the A's, B's, and C's as needed. So something squared minus 4. Then I plug in A and C. So I'm just copying from up here from the equation. It's going to go negative. I guess I can put parentheses. So I'm going to just substitute wherever I'm putting parentheses. -B plus or minus the square root. I'm going to put in B squared minus 4. Then I put in the A and the C, and that's all multiplication all over to A. So that might help you a little bit with plugging in the numbers. And I'll do the color again. So anyways, I was saying start with B. It is 3. So I'm using this equation. So I'm going to put a 3 here and here. You could go first with A, but A is inside the square root. So I just started with the first letter. So it's minus 4AC all over 2A. So I'm going to put the A in both of these spots. A is equal to 2. So I've got 2 and 2. And then my last one is C. From the equation, C is -5, so you have to make sure you get -5. And again, I got to make sure I can actually see that, so I'm going to put it in pen also, -5. All right, so I'm going to just go through and simplify. So again, PEMDAS really tells you to just start with the inside of the square root, start with exponents, multiplication. So I'm going to do -3 plus or minus the square root. 3 squared is 9, minus. All of that's multiplication, so I can just kind of multiply from left to right. You could do this in multiple steps, but it won't make a difference calculating it, so it's easier to just do it now. So 4 times 2 is 8, times 5 is 40, but that 5 is negative. So it's going to be 9 minus -40 all over 2 times 2, which is 4. So I still have some simplifying to do. One of the major things I'm seeing is I have a minus and negative. Be super careful. There's a minus, but then the 5 was negative. Those are going to cancel out, and I'm going to add those. I'm going to write it down here again. So -3 stays there, plus or minus the square root. 9 plus +40 is 49, all over 4. Okay, so once you get to this point, sometimes that's kind of like as far as you can get. That's all you can simplify. But I'm noticing I can actually square root 49. If it's a perfect square in there, go ahead and square root it. And then rewrite it -3 plus or minus 7 over 4. And now I can actually separate it, just like we did in the past with completing the square. I can make the two solutions. One of them is -3 plus 7 over 4. And then the other one is -3 minus 7. So one with the plus, one with the minus over 4. And then I just have to simplify. Negative 3 plus 7 is 4, so I get 4 over 4, which equals 1. Over here, I get negative 3 minus 7. Since they're both negative, you add them, negative 10 over 4. It doesn't divide, but I can reduce it. Divide top and bottom by 2, and it's negative 5 over 2. And you can leave your answer like that, or you can make it a decimal. You could have just divided it in a calculator. It would be negative 2.5. Either form is okay with me. All right. Oops, you can barely see that. Okay, so then to write my final answer, I'm going to go ahead and write x equals negative 5 over 2, comma 1. I'm going to make it a solution set. Just pay attention to how your answers are supposed to look. Maybe you have to put braces around it. Maybe you have to write it. Remember, you could have graphed this beginning equation. You could graph it in Desmos. Where it should have x-intercepts are negative 5 over 2, comma 0. That would actually be negative 2.5 in Desmos. That would be one x-intercept, and then the other one would be 1, comma 0. So that's something that's always interesting to see. How does the graph of it actually look? Because those would be the x-intercepts. That's what the solution is. All right, so that's pretty much it. We're going to do some examples in class. Make sure that you guys do get your 3 questions on the left and a summary at the bottom, and then turn into Google Classroom.